Okay, everybody, let's summarize the lesson. So what we talked about today is we want to talk about rational functions. And any rational function is going to be some kind of a fraction. So you see the word rational, it just means fraction, okay? Rational, think fraction. Let's see, where's a red pen? Rational, think fraction. So we started out the lesson, and I asked the kids to come up with all the multiples of 12. And so we wrote them as ordered pairs, 6 times 2, 1 times 12, 3 times 4. But since 2 times 6 is a different ordered pair, we wrote that as well. So we changed them around. So here's all the multiples of 12, including the negatives. Then we graphed them all, and it turned out to be a graph like this. So one of the things we know is that multiples of 12, what times what makes 12? You'll never get an answer of 0. You can never get a number. 0 times anything will never equal 12. So we know that 0 cannot be a number on either x or y. So what we ended up doing is the graph gets closer and closer to 0, but we get a thing called an asymptote. We get a horizontal asymptote here at 0, y equals 0. We get a vertical asymptote here at x equals 0. These are like lines of borderlines, right? It'll get closer and closer and closer and closer to that line, but never touch it. Same thing here, same thing here and here. So we've got a horizontal asymptote at 0 and a vertical asymptote at 0. So if we take a look at x times y equals 12, we can rewrite as y equals 12 over x, okay? That's a rational function. We have a fraction, okay? X cannot equal 0 because you cannot divide by 0. So you cannot divide by 0, okay? So if x is 0, it's undefined, and that's why we've got a vertical asymptote at 0, okay? Now, we also took a look at the parent function, 1 over x. 1 over x looks like this. Multiples of 1, 1 times 1, 2 times 1 half, and the negative. So there's my parent function. And then we took a look at if we moved it. We take a parent function, we move it. Well, so we took a look at a function that looks like this. We start with 1 over x minus 3 minus 2. Okay, we're going to graph this. But before we do this, we know that x cannot equal 0. Cannot divide. Do not divide by 0. Don't divide by 0, okay? So if x are 3, 3 is bad in this case because 3 minus 3 is 0. X cannot 3, so we put a asymptote at 3 because x cannot be 3. So when we graph this and we have our horizontal asymptote at negative 2, we graph this function here. You can see it goes off to infinity, off to negative infinity, off to infinity, off to positive infinity, but it's bound by these asymptotes. So then we looked at the domain and range. So the domain of the x is how wide, it's everything. It can be all real numbers except, it goes forever, except for it cannot equal 3. X, and then for the y's, equals all real numbers, but it cannot equal negative 2, okay? And that's what we had. I had a worksheet to go along with that. Pretty short lesson. And then we did a mathia to go along with it. Okay, that's all I have.